Okay, so this is the second period video. First period video, I did 1, 4, and 7. In this video, I'll do 2, 5, and 8. And then later today, I'll do 3, 6, and 9 with fifth period. So that by the end of the day, everything's posted. You can find what you're looking for, hopefully. Okay, so let's do number 2. Find dy dx if xy equals tangent of y. All right, this is about as straightforward of a problem as we'll get on this test. A little bit of product rule, a little bit of trig going on, but fairly straightforward. So first times derivative of the second, x times dy dx, plus second times derivative of the first, y times 1, equals, what's the derivative of tangent? Okay, secant squared. Yeah, you answered my question. Let me ask a better question. What's the derivative of tangent of y with respect to y? Secant squared of y times dy dx. Right? Keep the argument the same when you take the derivative, but then multiply by its derivative. Chain rule, right? Outside in, one layer at a time. Okay, so my calculus is done. Now I need to do some algebra. X dy dx minus secant squared of y dy dx equals negative y. So let's factor out the dy dx. X minus secant squared y equals negative y. Divide both sides by all of that. X minus secant squared y. Now, does that match any of my... It does not match any of my answer choices. So, what is going on here? Let's see. Is it A? They put the negative out front. That would just be taking this negative and moving it to the front. So I don't think it's A. What about B? If I multiply top and bottom by negative 1, it would make y positive, and it would switch those signs. So B looks good. I'm pretty sure it's B. Let's keep looking though. C is missing a negative in the top, so it's not C. D, it's plus in the bottom. That's definitely not right. So yeah, it's answer choice B. That's going to be one, hold on a second, that's going to be one where multiple choice is available. This happens to students. They get it to here, and then they can't use their algebra to figure out which one matches that. So on a 5-point problem, I'm probably only going to take off 2 if you made it this far, but then algebra lets you down.
So it's okay instead of moving secant squared over, we move x over to secant squared?
Yeah, so we probably would have got, if we move things over a different way, not even a better way, but a different way, and we left y alone, and we moved this over so it was secant squared y minus x dy dx. I'm going to go y prime because I'm out of space here. Then it would have matched up a whole lot easier to answer choice B. And honestly, I peeked ahead and saw that, but I wanted to work it this way so that we would be forced into reckoning with negative signs. So yeah, that's one of those, like, unless you're peeking at the answers and are doing a little bit of algebra in your head, how do you know which side to move it to? You kind of don't. And so if you go this way, you luck out and get an easy answer. If you go this way, it takes a little bit of algebra thinking negative signs to figure it out. Not a wrong way. Maybe a better way, but not a better way that you can know ahead of time, really. Other questions on number 2? Again, probably the most common mistake is leaving dy dx off somewhere. Like you get so excited that you remember the derivative of tangent of secant squared that you just put secant squared, something like that. Although this one was nice in that answer choice wouldn't be there, so maybe you could figure out you made a mistake. Number 5. Kind of a long one. Consider the curve given by this equation. Show that, oh, we like this, right? Like, here's the answer, just get there. Do you know why I would why I would phrase the problem that way, other than just out of the kindness of my heart?
You have to show all our steps.
Okay, so you have to show your steps to get there, but why wouldn't I just say find dy dx? Why am I giving you the answer? Do you know? The answer to that question is not really in part A, but in part B and C and D. It's so that, selfishly on my part, I'm giving you dy dx. You need it in part B and part C and part D. So if I ask you to find it and you mess it up, then you're going to mess up B and C and D, and I'm going to have to figure out what I'm going to do. Like, am I going to follow your work all the way through? Is it neat enough to follow through? Or was this answer so far off that it's not really worth it? I don't have to deal with that. I'm giving you the answer. But it does mean you got to show your work. Okay, so derivative of all of this thing with respect to x. No t's yet. So the derivative of y cubed is 3y squared. True or false? You like that? No, you don't like that. Why don't you like that? Yeah, dy dx. The derivative of y with respect to x. You need that dy dx on there. And then another product rule problem with a minus sign out front. So you can either like attach the minus sign to the x and then do the product rule, or what I'm going to do is just leave the minus sign out front, do the product rule on the inside stuff, and then handle the minus sign at the end. This one's straightforward enough. I'm not going to write out f equals g equals f prime equals g prime equals. I'm just going to do first times derivative of the second plus second times derivative of the first. And then a fun spot for students to mess up. What's the derivative of 2? 0. I don't think it's that they don't know the derivative of 2. I think that they get so tired or excited or whatever that they got this part right that they just write down 2 over there instead of thinking about take the derivative of everything. Okay, so dy dx, 3y squared minus x. I'm doing a whole bunch at once here. Equals y. So I distributed the minus sign, moved the y over, and then factored out dy dx. That's probably the outer limits of what I should be doing without showing steps. Especially since the whole point of this problem is to show your work. You guys are smart enough that every one of you, your last line is going to be this, right? Because you know that's the answer. Like, even if you can't get there, you're going to make that your last line, even if nothing else agrees with it, right? And hope that I don't pay enough attention to catch it, basically. I mean, as you should. Like, you know this is where your answer is, so if you can't get there, at least pretend you got there and write that as your answer and hope that I don't catch it. Plus, it's needed for the rest of the way. Write an equation for the line tangent to the curve. So I need a point and a slope. They give me the point. How can I find the slope of that line? The slope is the derivative. And I will evaluate that at negative 1, 1. Again, this is why we give it to you, so that you can get the rest of the problem right, even if you've missed part A. So 1 goes in for y. -1 goes in for x. That would be an okay way to leave it. It just looks messy, and I don't want to keep writing that, and it's easy to simplify. So 3 plus 1 is 4. So y minus the y coordinate equals the slope times x minus -1, so x plus 1. And that's point slope form. We like that. We're good with that. Check for part B. Part C. Find the coordinates of all points on the curve at which the line tangent to the curve is vertical. Vertical tangent lines. So those would be up and down. That's what vertical means. What's the slope of a vertical line? Algebra 1 students? And people always get it confused because it's this and this. One of them's 0, one of them's undefined. Which one is this?
Undefined.
Undefined. Right? It's like ski slopes, right? How fast are you going? If you're on a horizontal slope, well, you're not going very fast. Your slope is 0. How fast are you going if you unfortunately end up on a slope that looks like that? Or a better question is, what will you be when you get to the bottom of this? You will be undefined. How unfortunate. So undefined slope, up and down. How do you get undefined for an answer, though? Like, I know my slope, dy dx, we had that earlier, is... How do I get undefined out of that? What would make that undefined? It's even true way back in Algebra 1. All right, when you were doing good old change in y over change in x. If the bottom is 0, then it's undefined. Okay, so it's like 3 little Algebra 1 reminders there before we even get to the problem. Vertical is this way. That means slope is undefined. That happens when the bottom is 0. So 3y squared minus x equals 0. Except I can't, that has 2 variables in it, so I can't really, I mean, I guess I could solve for x. X equals 3y squared, but that's not really, that doesn't answer the question yet. Find the coordinates of the points. So this is true. This is where my slope is undefined. But I don't have anything else. Wait a minute, I do have something else. We've done this a couple times where you got to go all the way back to that original equation. Points on the curve are given by y cubed minus xy equals 2. So we're going to have to use both of these. This is where the slope is undefined. These are the points on the curve. So I can plug in 3y squared in for x. And now I've got all y's. Y cubed minus 3y cubed equals 2. Negative 2y cubed equals 2. Algebra fun all the way down here. So y cubed is negative 1. Which means that y is negative 1. Is that my answer? The answer is kind of. Why is that not all of my answer? I need the x coordinate. Find the coordinates. So y might equal negative 1, but I need to know what x is. I should be able to plug it into either one of those. Right? Systems of equation, once you find one of the answers, you can plug it into either one. Obviously this one would be a little bit easier to deal with. X equals 3 times y squared. So at 3, 1, that curve has a vertical tangent line. Sarah. At 3, negative 1, that curve has a vertical tangent line. Now, I'm going to show you something that you won't have access to on the test, but I didn't have the key handy, and I wanted to make sure I got this right, because that's a lot of work, a lot of steps. And so, again, you won't be able to do this on the test, but there is the graph. Desmos.com, it can graph all kinds of crazy things. There's the graph of y cubed minus xy equals 2. That was our original curve. So that's some weird, crazy graph, not even a function. And we said at 3, negative 1, it has a vertical tangent line. And sure enough, if we were to draw a tangent line to this curve right there, it would be a vertical tangent line at x equals 3. So, again, you don't have that on the test, but that's me checking to make sure that my answer is right. Part D. Evaluate the second derivative. Okay, we've done this a couple times during this unit. And yet again, a reason for me to give you the first derivative so that you don't mess up the rest of it, or at least you have the right starting point anyway. Evaluate the second derivative. Okay, well, quotient rule. This one's a little bit trickier, so I am going to take the time to write out f and g and f prime and g prime, and then I'll put it all back together. Derivative of f would be dy dx. Derivative of g would not be 6y minus 1. Why is it not 6y minus 1? I need a dy dx in there. Okay, so the second derivative then is gf prime. Got to keep the gf first. So that would be, I'm going to put dy dx in front. Dy dx times 3y squared minus x minus the other way around, y times 6y dy dx minus 1 all over 3y squared minus x squared. Now, depending on how the question was asked, it's possible that that would be the right answer. It's not here because we want to evaluate it at negative 1, 1. It also has a dy dx in there. But I think we already found dy dx at negative 1, 1. Like that was way back in part B. That was 1/4. Okay. Let me pause, because there have been times where we've substituted in this whole algebra statement in for dy dx, right? And then we have an algebra mess on our hands. But here, because we're plugging in negative 1, 1, I don't have to do that. I already know what dy dx is at negative 1, 1. So dy dx is 1/4. And then I'm plugging in negative 1 for x, 1 for y. 3 minus negative 1 minus 1 times 6 times 1 times 1/4 minus 1 all over 3 times 1 squared is 3 minus negative 1 squared Is that a safe stop? Yeah, it's calculator ready. Nothing but ugly algebra left. So we're good with that. Right? Why bother messing some of that up? Some of it would be easy. 4 times 4 would be 1. But then 6 fourths and 3 halves and squaring. Like, don't mess with that. Like, I'm out of time. I'm out of patience. I'm done with this. I'm out of space. Box it up and be done. Questions on any of that one? Lastly, number 8. A cylindrical tank is being filled with water at a constant rate of 4 cubic meters per hour. Okay, so something is 4 cubic meters per hour. What is that equal to in terms of my variables? What's meter cubed a measure of? Volume. So this is change in volume per time. So dV dt. Again, the rate tells me it's a derivative, and cubic meters tells me it's volume. The tank has a circumference of 20 meters. Why don't they just tell me what the radius is? But whatever. And a height of 40 meters. Volume is given by. Let's go ahead and figure out the radius, because I'm probably going to need that multiple places here. If the circumference is 20, 2 pi r equals 20. Notice we didn't give you that. We expect you to know the circumference of a circle. So r is 10 over pi. Part A. What is the volume of the water when the water is 25 meters deep? What is the volume of the water? Nothing's changed. Just what's the volume? So not dV dt, no dH dt. Just find the volume. Pi times r is 10 over pi squared when the water is 25 feet deep. And hey, it's a multiple choice question, so I don't really need to multiply all that out. I'm good. Would that be 2500 over pi? But why risk it? Leave it alone. Part B. At what rate is the height changing? So find dH dt when h is 25. V is pi r squared h. Okay, so I need to take a derivative to make dH dt show up. But there's an r in there. And, like, r is 10 over pi. Kind of 2 ways to handle this. If I take a derivative right now, I'll have to use the product rule. Is there any way around the product rule? Could I? Why am I allowed to plug in 10 over pi?
Because it's constant.
Good. That's the thing. It's not 10 over pi is not changing. The radius is not changing. So I can plug in 10 over pi and be okay. You got to be careful with that, because on one like number 9, where r and h are changing, you better not plug in either one until after you take a derivative. That was it? No? Okay. There's not a relationship between r and h either. So like on number 9, h is 3 times r, so that would help, but I don't have that here on this one, because r isn't changing. Okay, the best answer is r isn't changing, so it's not a variable, it's a constant. So I can just plug that in. So So the derivative is actually pretty easy because all of that stuff out front is a constant. And then the derivative of h should be dh dt. dv dt is 4. One of the pi's will cancel, so 100 over pi dh dt. Is that a safe stop? No, why not? Yeah, I got to solve for dh dt. Like, I'm almost there, but that's not calculator ready yet. Let's multiply by pi and divide by 100, and now we're good. And sure, that reduces, but I'm not worried about that. I'm good. It did not ask for unit. Oh, speaking of units, part A did ask for units. Units of volume would be meter cubed. Part B did not ask for units, but if it had, meter cubed per hour. They told us way long ago that dv dt was equal to 4.
Why is it meters cubed?
It would just be meters, yeah. I think my brain was stuck on part A with volume, but yes, height would be meters. Alright, so other videos will show other problems. Again, this one was 2, 5, and 8. So look for the other videos if you need the other ones.